Hey guys, how's it going? Welcome to my final project presentation for the Data Structures and Algorithms class. I have chosen CountingSort. Let's get started. What is CountingSort? Unlike merge sort, bubble sort, CountingSort does not compare the elements to arrive at the final sorted array. Instead, it counts the number of occurrences of each element and does an arithmetic calculation which serves as a base for sorting. CountingSort is used to sort integers whose range is known. The range is set from 0 to k, where k is the element with maximum value. Consider this array with integers 6, 3, 8, 2, 4, 3, 2. Here the number of elements is 7, therefore n is 7, and 8 is the maximum value in this array, therefore k is 8. How does it work? Let us see the working of CountingSort using an example. Consider an array with integers 6, 4, 0, 4, 8, 9, 6. Here n is equal to 7 and k is equal to 9. So we construct an array of size 10, that is from 0 to 9, and we initialize it to 0. Next, we traverse through the unsorted array and increment the corresponding index by 1 in the count array. For instance, the first number in the unsorted array is 6. So we increment the value in the count array corresponding to the 6th index by 1. We do this for all elements in the unsorted array. Our final count array looks like this. Next, we create a sum array of size 10 and we record the running sum of the count array here. Note that there is no need to create another array called sum array. We can record the running sum in the count array itself, but I am doing this for better visualization. To begin, 1 is copied as it is to the first position of the sum array. Then the 1 of the sum array is added to the 0 of the count array and is inserted in the second position of the sum array. Similarly, all the positions in the sum array are filled. Finally, we construct another array of size n. This will store our final sorted array. Once again, we traverse through the unsorted array. The first element is 6. Now, check the value in the sum array corresponding to index 6. It is 5. So, we insert 6 in the 5th position of the sorted array. Then, we decrement the value in the 5th index of sum array by 1. Then, we proceed to the next element in the unsorted array, which is 4. The value corresponding to the 4th index in the sum array is 3. So, we insert 4 in the 3rd position of the sorted array and we decrement the value in the 4th index of the sum array by 1. Repeating this process, we arrive at the final sorted array. Let us look at the pseudocode. First, we create the count array of size k and initialize it to 0. Next, we store the count of each element in this count array. Then we create the running sum in the count array. And lastly, we build the sorted array just as we saw in the previous slide. So what observations did we make? Very handy in sorting integers and especially when there is repetition. The time complexity is O of n since we visit all the elements of the unsorted list at least once. Space complexity is O of n plus k, where n is the number of elements and k is the range. Note that the counting sort is used only when k isn't very large compared to n. Consider an array with values 0, 4, 9 and 1 million. You will be unnecessarily using 1 million spaces to sort an array of 4 integers, which is not feasible or practical. What are the pros and cons of CountingSort? It is pretty fast and it's very easy to code. and cons is that it requires additional space of k. So that's it for CountingSort. Hope you understood what CountingSort is. I really had a great time in this class. Thank you everyone.